So today we are going to continue our model solution for empirical formula and molecular formula. So this number 7, zinc phosphide is made by heating zinc and phosphorus together. It is found that 8.4 gram of zinc combines with 3.1 gram of phosphorus. Find the empirical formula for the compound. So what we need to do is to find out the molar mass of zinc, okay, and also phosphorus. So the molar mass of zinc and phosphorus is, zinc is given as 65 and phosphorus P is 31. Alright, so 65 and 31. 65 and 31, so we can start with solving this. So zinc, phosphorus. Molar mass 65, so 8.4 gram divided by 65, and then that's the mole, number of mole. Here 3.1 divided by 31, so this one is 0.1 mole, and this one is calculator 8.4 divided by 65. That will give us the figure of 0.13. Okay, so this one is 0.1 and the other one is 0.13. So we need to find the empirical formula. So this one, the ratio is more or less the same, so we have ZnP. Okay, zinc phosphide, because 0.13 and 0.10 is quite close, so we consider them ZnP. Now the next question is number 8. Indigo is a dye used to color sweets and cakes. Indigo contains 73.3% carbon, 3.81% hydrogen, 10.69% nitrogen, and 12.2% oxygen according to mass. Determine the empirical formula of indigo. Let's clear this page and let's give up some more space for indigo. So this one we follow the same procedure. We are going to write out all the elements C, H, and O. Right? So we need to assume that there is 100 gram of compound. So all this percentage we can change it to gram. 73.3 gram, 3.81 gram of hydrogen, 10.69 gram of nitrogen, and 12.2 gram of oxygen. So what you need to do is you need to find the number of mole. 73.3 divided by 12, that will give you 6.1 mole. Now how about 3.81? 3.81 divided by 1 is just 3.1, right? So you don't have to press calculator. Third one, 10.69 divided by 14, because the molar mass for nitrogen is 14, so it gives you 0.76. And the last one, 12.2 divided by 16, molar mass of oxygen, that will give you 0.76. Right? So now you see that they have 6, 3, 0.7 and 0.7. So we need a whiteboard, right? Or we can use the smaller number. So among these four, which one is the smallest number? Is it 0.76? So what do you get if you use 6.1 divided by 0.76? 6.1 divided by 0.76. So you get 8, right? How about 3.81 divided by 0.76? So this one is 8. 3.81 divided by 0.76, that will give you 5. And 0.76 divided by 0.76 is just 1, and the other one is also 1. So okay, so it's C8, H5, and NO. Let's clear the page. So it will be C8, H5, and O. Alright, that is because just now we have some figure, we divided by the smallest number. Right? So that will be indigo. So let's look at number 9. Nicotine is compound found in tobacco. It contains 74.1% carbon, 8.64% hydrogen, and 17.26% nitrogen. Determine the empirical formula of nicotine. So with the same method, we can just put carbon, hydrogen, and nitrogen. And this one is 74.1 gram, and this one is 17.26 gram. And you also have the rest of it. No, hydrogen is 8.64. Sorry for the mistake. So hydrogen 8.64 gram, and nitrogen is 17.26 gram. So how much is the number of mole for carbon if 74.1 divided by 12? What do you get? You get 6.18. How about the number of mole for this one? No need calculator. Number of mole is simply 8.64 because it's divided by 1. So you get 8.64. How about 17.26 divided by 14? That will give you 1.23. So how about 6.1 divided by the smallest number? 6.18 divided by 1.23. What do you get? You get 5. Alright. How about 8.64 divided by 1.23? 1.23. So you get 7. Alright. How about 1.23 divided by 1.23? You get 1. So C5H7 and 1. Okay, so that's the formula for nicotine, C5H7N.